Hi, I'm Matt Needham, and this is my tool lab demonstration. Let's start off with the hallmark tool of the air conditioning and refrigeration trade, the gauge manifold. Let me show you how to manipulate this. We're going to hook up the yellow hose, which is the charging hose, which is a 1/4 inch female flare connection here. We're going to take off the cap that we have on there, which you also have the same Schrader cap on air conditioning or refrigeration systems. Let me give you a service tip at this time. A good habit to develop is to take the caps and put them on the back of your gauge manifold. That does two things for you. Number one, you won't lose them, and you're not going to be able to forget to put them back on, because when you go to reattach this, you'll be like, oh, there's the cap, let me put it back on, whether it's the system or your tank or what have you. So I'm going to hook this up to the R22 cylinder, and before I open the cylinder, let me put my safety glasses on. And for right now, we have air in here. If you're going to charge a system, you've got to purge a little bit. You've got to get the air off the top so you're not adding air and refrigerant, just pure refrigerant. So let's do a purge on that at this time. I'm going to gently open the cylinder, and then I'm going to purge till I hear it. No. Okay, so I purged that, and then I just happen to have a cap on here to show you that without the red hose, I'm reading a pressure here of about 120 psi on the red gauge right there, because this is open and it's allowing the refrigerant to come over here, and I could do some charging on the high side of the system if the system was empty, if I wanted. So let me put this back for a second. Okay, so I have that pressure there. And then I also have the low side hose, the blue hose, hooked up to a vacuum pump. And you can see the vacuum pump over here. And we generally keep this valve closed so that atmosphere or air can't get into our vacuum pump and corrupt our oil. So right now I have the gauge manifold, the blue gauge handle closed, and I'll just be evacuating this blue hose. So I'm going to open this and gently turn on the vacuum pump, and then we should be seeing the pressure drop down here on the blue hose, and we're seeing it drop down into the green, into inches of mercury vacuum, getting right down there at around 28 inches of mercury vacuum. And if I want to make sure that my hose, we can shut this off and valve this off and make sure everything is tight, and that if the pressure starts rising up, then I know that I actually have a problem, a leaky hose or a leaky gauge or something like that. So that's even a test you can do. But normally, if I were to hook up this yellow hose there, and then this to the low side and the red to the high side, and open the gauge manifold, I can evacuate my system. When you have this closed, you're actually reading the pressure on the blue hose. When you have this closed, you're reading the red hose, and if you open it, it becomes common to this port. That's where the manifold part comes in. This part here is the manifold, and when these are open, this all becomes common to each other. So again, in reading it, 120 on the high side and around 28 inches of mercury vacuum there. Let me get this out of the way. I was worried about everything falling. I have it very precariously set up in my closet here. Okay, let's move on to some other demonstrations that we have. Let's go with the multimeter. we have the multimeter here on the attached to my whiteboard. And multimeter generally means volt, ohms, multi, two things or more. And most multimeters do many things for us now. But let's take a couple of basic readings. And I have this extension cord plugged into an outlet. And if I put the multimeter on volts, right now you can see that you're not reading any voltage, just air. And then if I put the meter leads in here, we should read a voltage of, I hope you can see that, maybe you want to plus that up, 120 volts. So we can take voltage readings in systems, look for voltage drops, things of this nature. So that's volts. And also let's put it and do some ohm checking here. So remember, checking your meter, a good thing you should always do, and this also can verify the battery strength and the calibration of the ohm meter, is put your leads together and you should be reading 0. I'm reading, come on, 0.2. That's very good. Sometimes if you start reading 0.7, 8, 9, it means your battery's probably weak and you need to change it. Things that should be reading 0 ohms are a closed set of contacts, a fuse that we have right here. That's reading the 0.2. An overload on a compressor, that should be reading pretty close to 0 also, 0.2. Now things that measure a measurable resistance of ohms are electrical loads. And electrical loads, like our contactor coil here, 10.8 ohms. Now, also just to get a sense of it, let me take my gloves off. And even our bodies, and everybody, the older you are, the more calluses you have, the bigger you are, the higher your resistance. And I've ohmed out maybe 700, 800, maybe 1,000 people in my lab classes. So if I pinch this here, and you have to pay attention to the ohm meter and what it says, it's saying M. So I'm about 1,100,000 ohms across my skin. If it was like 2 or 3 ohms, all the times I've worked in the trade and been shocked, if I was 2 or 3 ohms, I would have been dead by now. But now, having 1,000,000 ohms, all I've done is, you know, lost some hair. Okay, so that is the multimeter. You can a lot of times check microfarads with it and check capacitors. Let's move on. Also, we have here a jumper wire on our thermostat. And if you were to think that your thermostat is bad and then it's open all the time, having infinite ohms, and you put a jumper across this and then the machine turns on and works, you'll know that that's the only thing open in the circuit. So we use jumper test leads to do things like that. You don't want to leave a jumper test lead jumping out a safety permanently or for more than a few seconds, anything like that. So we also can use our jumper test lead for troubleshooting. We have now, in not so much residential but commercial industrial, our serviceman's ratchet wrench, reversible ratchet box wrench, and we use this to open and close service valves, suction service valves, discharge service valves, liquid line service valves known as king valves. The smaller one we can use to open an acetylene cylinder. You can use one of the settings to manipulate a pressure control. You can also use this to adjust the superheat setting on a thermostatic expansion valve, and you'll see that it has this kind of square, that's what we call box end type wrench. And then we have here some aviation snips, straight aviation snips for cutting sheet metal, and we would use the right-handed snips. and let me demonstrate this way for you a little bit. If you're going to cut with your right hand and cut a circle in this way, you see how the beak is kind of pointed that way, and traditionally those are colored red, and then the green handled ones is left-handed. So we have generally three kinds: straight, right-handed, and left-handed, depending on what sheet metal cut we might need to make. Now, our air conditioning refrigeration units are put together usually with 1/4 inch, 5/16 or 3/8 inch hex head screws, and this is a 5/16 nut driver, and this is what we use to take and put them in and take them out. I don't always, maybe I'm a traditionalist, I don't always use a cordless drill or something. If it's just one panel I have to take off, I don't always carry that with me, but this is certainly a handy tool, and the three most common sizes, again, for nut drivers in the air conditioning refrigeration trade are 1/4 inch, 5/16, and then most big package units are put together with 3/8. Okay. And then we have here what's called a hand seamer. This is where you can grab a piece of sheet metal and bend it and make like an angle with it, a hand seamer. This is a Schrader core remover that you can isolate the Schrader and take it out and turn it. Schrader core remover. Okay. This is something you've probably seen a lot of, even if you haven't been air conditioning refrigeration with the whole COVID thing. This infrared thermometer. Let's see how. Oh my God, I think I'm sick now. So this is good. Don't totally fall in love with this. Sometimes we need to actually take air temperature, but this can do a lot. This can tell you pretty much the temperature at the supply air grill or the return air grill, things like that. It's great for taking temperatures remote. You don't always have to get your ladder to take the air temperature coming out of a vent. A couple things it doesn't work on really great is if there's moisture like condensation on a suction line or ice. You will be deceived by using this, but this is a really handy tool that didn't exist when I started in the trade at the ripe old age of 17. 10 years ago now. Okay, so now we have here kind of a favorite tool of mine. This is the all-purpose electrician's tool. Let me say something about this. Is for everything that it does like 5 jobs. It doesn't do any of them great, but it's a very handy tool. And the reality is, if you're doing air conditioning, refrigeration, service work, which I've done, a lot of times you just have to strip a couple of wires on a motor, cut a couple of wires, cut one machine bolt, bend one wire. So yeah, you can definitely strip wire with it. It's not the best, but you can strip the wire here like this, and also you can bend the wire if it's a solid wire with that function right there. You also have these, which you can screw your machine bolts, which are below a 1/4 inch bolt. We call them machine screws, and you can put them in there and then just squeeze that and it'll snap it off pretty clean for you. We also have crimping functions here to crimp connectors onto wires, things of that nature. And if you're going to be doing a lot of wire stripping, like a whole bunch, and when I was an apprentice, they first started making these sort of energy management panels, actually, that had timers in them. You can use these automatic wire strippers, which can strip wires for you very quickly. I will say that these tend to rust. Keep them out of the weather, and lubricated with WD-40 to keep them in good shape. But you can find the right size. Let's see if we can do this live. And strip wire, yeah, it's going to give me a little, I should have maintained this before I started. There we go. Yeah, this thing needs a little love. I should have cleaned it up before we started. To strip wire, automatic wire strippers. Okay. And this is a caliper for measuring things very exactly. In fact, this measurement here was an inch of the king, and how they developed what an inch is was the measurement on the king's body, an inch from the tip of the finger to the nose, a yard, right? A foot was the king's foot. So that's an inch, right? And then the inside diameter, an inch. You can measure inside diameter, outside diameter on something very exact with a set of calipers. Now let's look at this. I hope this stays together. I worked hard on it. On this puller configuration, and I had to use a pair of vice grips to simulate a pulley. But if I want to pull this off and I turn this way, then we can see that it's pushed. The puller, which I'm manipulating, is pushing into the shaft, and then these arms are going to pull the vice grip off. But you know, normally we would have like a coupling or a pulley. So this is a pulley puller that you can screw off, and I'll give you a couple tips on that as I take a break here. I've broken them before. Sometimes bearing jobs aren't that difficult. They'll come right off. Other times you just like, please, come on. Something's stuck. Some tips: take out set screws, anything you can take out completely. Spray some kind of really good break-free, or they have newer WD-40 that has a loosening effect to it. Spray that into any little hole or anything you can, and then put the like Allen screws back in loosely, and then go off and get your parts and prepare and do all of this and let that insinuate in there. Vibration is your friend. Consistent vibration can loosen things. Also, I've had the thing where I've done everything I can and I'm cranking on a giant, 14-inch adjustable wrench on a giant puller to try and get a coupling off or a bearing off or a pulley off, and I feel like, my goodness, I'm going to break something. You know what? Leave the tension on there. Spray it down again. Go to lunch, and then maybe just with that consistent pressure over time, it will get past a little rough spot on the shaft and free it up for you. So there's some tips for you. Also, on the shaft of your thing, although it's a small thing, when you have a shaft, yes, you can sand it down, but when you're done, your sand cloth, once you prepare, try and clean as much as possible before you start your job. This will get worn down, which is good, because then you can sand in the direction of travel just for 5 seconds. Just so you don't have those scratches opposing the direction of travel. It's a small thing, but it only takes 5 seconds. Now, let's look at some copper tools here. Here is a tubing cutter, and you put it on your soft drawn copper tubing, and then you turn this around, and as you turn it, you tighten it a little bit on the knob, and then you keep turning it until it cuts. Now, I just turned it a few times, and I need to tighten the knob, and there's a cutting wheel on there that is going to cut for me. Okay, and I'll show you when I'm done. Okay. Okay, that cut that off of there, right? Now let's say I need to ream or clean this out. We have an inner-outer reamer that we can use to clean the pipe, get the burr out, smooth out the outside, right? And we can use our sand cloth to do that. I actually prefer for the inner reamer something like this. I just find that you can get a cleaner way out of there with this. So that's very clean. And then again, I would use the sand cloth to clean the outside of my pipe. many techniques, but if you just have a small piece like this in your hand, you can shine it up. And again, the cleaner a pipe when you go to solder or braze it, the more likely you are not to have leaks. So you want to spend that extra minute and really clean it up nice and shiny, so you don't have any impurities in there. Make sure there's no grit left on it. And as you do that, then you'll have a nice clean piece of copper. See how the end is clean now, so that you can braze it or solder it. Also, with flaring, we have the flare block or flare bar and the yoke. My yoke is kindly and my load is light. And you want to imagine, it's sometimes if you're doing a lot of it, you can use a penny or a dime or whatever, or a nickel, based on the size of the copper above the flare bar. But if you just want to visualize for each size of copper that goes in here, when I squash it out, will I almost fill up the entire shape of the flare? Okay. Also, I put just a drop of oil on there. You're supposed to use refrigeration oil, but I didn't have any handy here at home. I used a drop of vacuum pump oil, but I'll wipe that off when we're done. And you put in your yoke and your over the top of your flare bar or flare block, and then you tighten it. And then you tighten it a little bit and you loosen it, and then you just keep tightening it until you reach the end, and then you flatten it out so it really forms the shape. Loosen a little bit, tighten. Come on. It almost seems like I haven't used this guy in forever. I doesn't make sure that I get it right. Okay, now we'll make sure it's okay. Now we loosen it. We take this off, and then we can put a flare nut, and make sure you put your flare nut on ahead of time. But then you have a nice flared fitting. You take that out of your flare block or flare bar, and it would be ready to connect, and it should look something like this, and then the flare nut comes over the top and seals onto the male fitting. And it's actually similar to, let me remove this, the vacuum. I'll show you. It should line up like with the size of this, okay? All right, so, well, that actually, no, that one was 1/4 inch. This is 3/8, but I was just showing you the type of fitting there for the flare. And that concludes my demonstration lab on using the tools of the HVACR industry, or at least some of them. Thank you.